Assalamu alaikum everyone. In this video, I am going to cover the whole exercise 5A of chapter 5 linear equations and simple inequalities. Let us start with the basic algebraic concepts. First of all, we have an algebraic equation over here, that is 5x plus 10 is equal to 0. Well, an equation is all about equating one quantity with another. In simple words, we can say that an equation means equality. That is why the equation has the equal sign. An algebraic equation is a mathematical statement in which two expressions are set equal to each other. The equation 5x plus 10 is equal to 0 consists of many parts. Now let us discuss those parts. These parts of the equation 5x, 10 and 0 are called algebraic terms. A term is either a single number, as we have 10 in the given equation, or a variable, as we have x in the given equation, or variables and numbers multiplied together, as we have 5x in the given equation. While 5x plus 10 is equal to 0 is an algebraic equation, 5x plus 10 is called an algebraic expression. An expression contains variables, constants, and algebraic operations. Now let us discuss about variables, constants, and algebraic operations. A variable is a symbol for a number we don't know yet. It is basically an unknown value. It is usually denoted by a letter like x or y. In the given equation, our variable is x. A constant is a number on its own. That is, it is not being multiplied by a variable. That is why its value doesn't change. In the given equation, our constant is 10. A coefficient is a number that is being multiplied by a variable. In the given equation, our coefficient is 5 that is being multiplied by x. 5x means 5 times x. Algebraic operations mean addition, subtraction, multiplication, division, raising to a power, and extraction of a root. Now let us learn about linear equations. Linear equation is any equation having the highest power 1 and hence represents a straight line on a graph. Well, there is no limitation on the number of variables you have in a linear equation, but the limitation is on the degree or highest power of the variable. For an equation to be linear equation, the highest power should be 1. In chapter 5, we are going to learn about linear equations in one variable. Linear equation in one variable is any equation having only one variable with the highest power 1. It is also called first degree equation in one variable. To find whether an equation is a linear one or a non-linear one, you need to check the degree of the equation. By degree, I mean the highest power of a variable. Here are some examples of linear equations. In the first example, we have x plus 3 is equal to 7. As the degree or highest power of the variable x is 1, therefore it is a linear equation. In the second equation that is given over here, 3 over x is equal to 5, the degree of the variable is also 1. In the third example that we have over here, x plus y plus z is equal to 10. We are having 3 variables, but we know very well that there is no limitation on the number of variables we have in a linear equation. The limitation is on the degree or highest power of the variable. As the degree is 1, therefore it is also a linear equation. Here are some examples of non-linear equations. In the first example, you can see that the degree of x is 2. Therefore, it cannot be a linear equation. In the second example as well, you can see that the degree of x is 3. Therefore, the second equation is also not a linear equation. The third equation that we have is 3xy plus 2x plus 2y is equal to 11. In this equation, you might have noticed that there are two variables in the first term, that is 3xy. Therefore, the total degree of the term is 2. By total degree, I mean the sum of the powers of the variables x and y. Therefore, it is not a linear equation. The fourth equation is 3x plus 5 over x is equal to 0. In this equation, the power of first variable x is 1, but the power of second variable x is minus 1. Therefore, we need to minimize the power, after which the equation becomes 3x square plus 5 is equal to 0, which is why it is also not a linear equation. Now that we have learned about algebraic equations, let's solve them. Well, solving an equation means finding the value of the variable that satisfies the given equation. That is the value that equates the left hand side and the right hand side of the equation. The equal sign in an equation means that the total value on the left hand side of the equation must be the same as the value on the right hand side of the equation. When we find the value of x in any equation, it is called the solution of the equation. There are two methods of solving equations. The first method is called transpose operations method. While solving an equation by this method, you need to keep the variable on the left hand side of the equation and move all the other items to the right hand side. And while you transpose or transfer the terms to the right hand side, remember that whenever a term is added on one side of the equation, you can transpose it to the other side by subtracting it. The converse of this concept is also true. That is, when a term is subtracted on one side of the equation, you can transpose it to the other side by adding it. And whenever a term is multiplied on one side of the equation, you can transpose it to the other side by dividing it. The converse of this concept is also true. That is, when a term is divided on one side of the equation, you can transpose it to the other side by multiplying it. For solving an equation by transpose operations method, you must remember these concepts. The second method is called inverse operations method. While solving an equation by this method, you need to remember the simple concept that whatever you do on the left hand side of the equation, you need to do the same to the entire right hand side of the equation. That is, if we add a term on the left hand side, we need to add it on the right hand side as well. The converse of this concept is also true. That is, if we subtract a term on the left hand side, we also subtract it on the right hand side. And if we multiply our left hand side by a term, we also multiply our right hand side by the same term. The converse of this concept is also true. That is, if we divide our left hand side by a term, we also divide our right hand side by the same term. For solving equations by this method, you must remember these concepts. Now that we have learned about both the methods, transpose operations and inverse operations, let us solve an equation by using both the methods. The equation that we have over here is 2x plus 4 is equal to 10. Since our aim is to keep the variable on the left hand side, let us transfer all the other terms to the right hand side. As 4 is added on the left hand side, so when we transfer it to the right hand side, we subtract 4. We can write the equation as 2x is equal to 10 minus 4. 10 minus 4 is 6. So we have 2x is equal to 6. Here you need to remember that 4 is an existing term and you are not adding or subtracting it. You are simply transferring it to the other side by changing its sign. Same goes for 2. As we need just x on the left hand side, now it's time to get rid of the 2. The 2 that we have on the left hand side is being multiplied by x. So when we transfer it to the right hand side, we divide it. We can write the equation as is equal to 6 over 2. 6 divided by 2 is 3. So x is equal to 3. Now let us solve the same equation by inverse operations method. To solve by inverse method, we must remember the concept that whatever we do to the left hand side, we also do it to the right hand side. Now as we need to keep x on the left hand side, we need to get rid of 4. for which we will subtract 4 from both sides. We can write the equation as 2x plus 4 minus 4 is equal to 10 minus 4. 4 cancels out on the left hand side and the right hand side equals 10 minus 4. 10 minus 4 is 6, so we can write the equation as 2x is equal to 6. Now as we need to have just x on the left hand side, we have to eliminate 2, which we can do by dividing the left hand side by 2. And as we know the rule that if we divide the left hand side by 2, we have to divide the right hand side by 2. So we can write the equation as x over 2 is equal to 6 over 2. 2 cancels out on the left hand side and 6 over 2 equals 3. So our final answer is as x is equal to 3. We can also verify our answer by simply substituting the value of x into the equation. And the value of x that we found out in the previous question tells us that if we place the value of x is equal to 3 in place of x in the equation, we will get 10. Now let us substitute the value of x in the equation. We have 2 into 3 plus 4. 2 into 3 is 6, so we have 6 plus 4 is equal to 10. As we have equated the left hand side and the right hand side of the equation, it means our answer is correct. Now that we have learned about both the methods, transpose operations and inverse operations, let us solve some questions from exercise 5a. Well, you can use any of the two methods that you prefer. I am using transpose operations method to solve the equation that is given over here. In the given equation, we have a single variable and two different constants. Since our aim is to keep the variable on the left hand side, we will transpose the 2 to the right hand side. As 2 is subtracted on the left hand side when transposed to the right hand side, it will be added over there. We can write the equation as x is equal to minus 5 plus 2. When the numbers have different signs, we do subtraction. 5 minus 2 is 3. And as we take the sign of the bigger number, the final value of x becomes x is equal to minus 3. In this level 2 question, we have two constants and a single variable with a number, that is a coefficient. Since our aim is to keep the variable on the left hand side, we will transpose the 4 to the right hand side. As 4 is added on the left hand side when transposed to the right hand side, it will be subtracted over there and the equation becomes 2x is equal to 18 minus 4. 18 minus 4 is 14, so the equation is 2x is equal to 14. As 2 is being multiplied by x, when transposed to the other side, it is divided over there and we have x is equal to 14 over 2. 14 by 2 is 7, so the final value of x is 7. Level 3 question, we have two constants, but we have the variable x on both sides of the equation. Since our aim is to keep the variables on the left hand side, we will transpose the x to the left hand side, that is 5x plus x. Likewise, we will gather the constants on the right hand side, that is 10 plus 2. 5x plus x is 6x and 10 plus 2 is 12. So we can write the equation as 6x is equal to 12. As 6 is being multiplied by x when transposed to the other side, it will be divided over there and we have x is equal to 12 over 6. Well, 12 by 6 is 2, so the final value of x is 2. In the level 4 question, you might have noticed that the variable x is given as a denominator, while in all the previous questions that we have solved, it was given as a numerator. Let us solve this question by cross multiplication. As we know that when a number has no denominator, its denominator is 1. Therefore, we can rewrite the equation as 2 over x is equal to 6 over 1. After cross multiplication, we have 2 into 1 is equal to 6x. As 6 is being multiplied by x, when moved to the other side, it will be divided over there. 2 by 6 is 1 over 3, so the final value of x is 1 over 3. Fifth and final question, we have a fractional equation to solve. A fractional equation is such an equation in which one or more terms is a fraction. In the given equation, we have a mixed number 2 whole 3 over 4 and a fraction 1 over 2. Here our first step will be to change the mixed number into a fraction, that is 11 over 4. That is quite simple to do. We can obtain 7 by multiplying 4 by 2 and adding 3 to the product. And as the denominator stays same, we have 11 over 4. The equation becomes 7x minus 11 over 4 is equal to 1 over 2. Since our aim is to keep the variable on the left hand side, we will move the fraction 11 over 4 to the right hand side. As the fraction 11 over 4 is subtracted on the left hand side, when transposed to the right hand side, it will be added over there. To add both the fractions, we will change them to like fractions. That is, we will express them in the same denominator. We will multiply the fraction 1 over 2 by 2 to have the same denominators. Well, we can rewrite 2 over 4 plus 11 over 4 as 2 plus 11 over 4, that is equal to 13 over 4. On the left hand side, as 7 is being multiplied by x, when transposed to the right hand side, it will be divided over there. So we have x is equal to 13 over 4 into 7. 4 into 7 is 28, so our final answer is 13 over 28. I hope that you found this video useful. Subscribe for more videos.